Okay, this is page 340, number 2. An 18-kilogram suitcase falls from a hot air balloon that is at rest at a height of 385 meters above the Earth's surface. The suitcase reaches a speed of 30 meters per second just before it hits the ground. We're going to calculate the change in internal energy of the system. So what I'm thinking here is that there is some energy loss to air resistance. So let's say the start is up here and the finish is down here. Let's make H equals 0. The ground here. So the energy that the block has, or the suitcase has, at the beginning of the problem is mgh, where h equals 385 meters above the ground. Okay, there's no kinetic energy here because they said it's dropped from rest. Okay, so the mechanical energy here is mgh. Now at the end here, we've reached the ground, so there's no gravitational potential energy, and the kinetic energy is 1/2 mvf squared, and we're told that that is 30 meters per second. There's no spring involved, so I'm going to ignore that. So if there were no non-conservative forces like air resistance, we could set mgh equal to 1/2 mv squared and solve. However, we're given all of that data, so let's see what we have here. The initial mechanical energy here, if you do mgh, you get 68,000 joules, all right? And if you do the final mechanical energy, you get 8,100 joules. Right, so I just plugged and chugged to get those in there. So what's happened here is that mechanical energy was not conserved. We lost energy to heat, right? Internal energy of the system. If you use the block, or the suitcase and the earth and the atmosphere as the system, well, the atmosphere is going to warm up a little bit. The suitcase is going to warm up a little bit. The ground is going to warm up a little bit, and that's just internal energy. So what we have here just is a work energy problem. We have the mechanical energy plus the work done on the system equals the final mechanical energy. And so the work done is just equal to the final mechanical energy minus the initial mechanical energy. And when you do the math there, you get about 60,000 joules. 60,000 joules of work was done on the system that was converted into internal energy. So that's the answer for question number 2.